This is the third video for Unit 1, and this video is going to focus on scientific notation. Not just the basics, because I'm guessing you know some of the basics of scientific notation, but it's also going to talk about how to do calculations with scientific notation and take into consideration significant digits. Okay, well, let's start out with the basics. Scientific notation has a coefficient and an exponent. So if I have the number 4 times 10 to the third, okay, 4 is my coefficient and 3 is my exponent. Okay, hopefully that makes sense. You can have an exponent that's positive or negative. If it is positive, that means it is a larger number. Okay, if it's, let's say we have 3 times 10 to the negative 3. If it is a negative exponent, then that means we have a small number. Pretty basic. Excuse me. Now, scientific notation has to be written in such a way that you only have one digit to the left of the decimal point. So if I'm writing scientific notation, I can't have, say, 14 times 10 to the fifth, 14.5 times 10 to the sixth. Okay? We would have to correct that. So in order to do that, I need to move this decimal point over from between the 4 and the 5 over between the 1 and the 4. And when I do that, that changes my exponent. And here's how I try to remember it. If I move this decimal point to the left and make my coefficient smaller, then I must move this exponent higher. So if this goes down, the exponent goes up. If the coefficient, if I'm making it larger by, say, moving the decimal point to the other side of the 5, then I would have to make my exponent smaller. So let's do a couple. Let's fix this one. I would have to move the decimal point to between the 1 and the 4. So I would have 1.45 times 10. And again, since I made this coefficient smaller by one digit, then I have to make this larger by one digit. Let's try another one. Let's say this is written incorrectly in the other direction. And let's do times 10 to the fifth here. Okay, I need to have a digit that isn't a 0 and just one of them to the left of that decimal point. So I have to move this decimal point over 2 places. So this would be rewritten as 4.56 times 10. And again, I'm making this larger. So I have to then bring down the exponent. I'm making this larger by 2 digits. So then I have to make the exponent go down by 2 digits. So this would now be to the third. Okay, hopefully that makes some sense. Let's try one more just to make sure that this is making some sense. Let's try 345 times 10 to the negative second. Okay, as you probably guessed, I'm going to put that decimal point between the 3 and the 4. I'm going to move it over 2 places, and I'm making this coefficient smaller, which means I'm going to make this exponent higher. So if this goes smaller by 2, this goes up by 2. Now, be careful. You have to think of this as like a number line. If negative 2 goes higher on the number line, this would be to the 0, and that means we would get rid of it. Okay, one other thing I want you to notice here, I kept my significant digits when I changed things. I had 3 significant digits here, and I have 3 significant digits here. I have 3 significant digits here, and if you look, those zeros at the beginning, remember those don't count because they're to the left of a number. Yes, I have a decimal point, but they are to the left of that number. So I have 3 significant digits when I rewrote this. Make sure that you're consistent with that. Significant digits don't change just because we're working with scientific notation. All right, so let's try some example problems with this and see if this is helping. I'm going to convert the numbers to proper scientific notation and significant digits. So I've got to keep that in mind when I write these. So my first one is 17,200. So this is 1.72. Those zeros over there, those zeros are not significant. And I know they're to the right, but there's no decimal point. So I'm going to leave those zeros off. And this is going to be times 10. And we're going to go over here and look. This is a big number, so this is positive exponent. 1, 2, 3, 4 places. So this is to the fourth. The next one, I have 0.0001700. Okay, those zeros to the front there, all of those to the left of that 1, none of those are significant. So I don't include those. My scientific notation is going to start with the 1, 0.7. The zeros on the end, those 2 there at the end, those count. So I have to include those in my scientific notation. And this time, this is a small number. So I'm moving my decimal point over 1, 2, 3, 4 places. But it's not going to be to the positive 4. This is to the negative 4. Because I'm moving this, if you think of it this way, I'm taking my coefficient and I'm making it bigger by moving the decimal point to the right, which means my exponent has to go down. Okay, C. I have 1,400,900. But I notice there's a decimal point on the end, which means I have to include all the zeros in that digit, or sorry, in that number. 1.400900 times 10, and this decimal point moved over 6 places, making this digit smaller, means my exponent goes up 6. D, this is a pretty easy one. Those 2 zeros in the front don't count. Those are insignificant, so we don't include it. This is 3 times 10, and since we went backward, this is to the negative second. E. E is 1800, no decimal point, so those 2 zeros on the end are not going to be included. 1.8 times 10, and because this is a larger number, I'm making my coefficient smaller by moving that decimal to 1.8. So this is times 10 to the third. All right, we have a couple more. Let's try a few more. Example problem number 4. Okay, I have 3.14 times 10 to the second, and it says convert these to ordinary notation. So I know that second is it's a positive exponent, so this is going to be a larger number, which means I'm going to move the decimal point in my coefficient over 2. So this is 314. So larger than the coefficient that we started with. The next one is similar. I have 3.14, but this is to the negative second, which means this is a smaller number, and that decimal point needs to move over to the left 2 places. So this is 0.0314. Now you might be asking me at this point, do you have to include that 0 to the left of the decimal point? No, you do not, but I tend to do that just to make sure that you see the decimal, just so there's no mistakes in the numbers that you're reading off of any of the presentations. 4 times 10 to the second, again, this is a positive exponent, so this is going to change to 400. Note, I did not put the decimal point there, okay, because this C has 1 significant digit, and so does this without the decimal point. Now, if I were to put that there, then I would be wrong, because now this has 3 significant digits, and my scientific notation originally had 1. So we have to leave that off. The next one, 9.87563. Now, if we notice, those are all significant, so I'm going to need to use every single one of them. The 3 here means that we're going to move the decimal point over 3 spots. So this changes to 9,875.63. So I moved my decimal point over from here to 3 places and made this a much larger number. Almost done. 9.1 times 10 to the negative 3. So this is a much smaller number, so I'm going to put a 0 there in the front. And this has to move over 3 spots, which means I'm going to have to put 2 zeros in there. Again, look, I have 2 significant digits on E over there, and I have 2 significant digits over here. Those first 3 zeros don't count. Okay? All right, now for the hard part. When we are using scientific notation and we are multiplying or dividing, the rules still are the same as we saw before, and those are pretty easy. However many number of significant digits you have, that's how many have to be in your answer. However, when we are adding and subtracting scientific notation, like this first one here, we can't just go by those rules. And in addition to that, we also cannot add scientific notation unless these are both in the same exponent. So over here, I'm going to just rewrite this. I have 2.30 times 10 to the fifth. Okay, and I'm trying to add this to 1.8037 times 10 to the third. Okay, so if I'm looking at these two, either this 5 is going to change to a 3 or this 3 has to change to a 5. So it doesn't really matter which one that you pick, but I'm going to pick this top one, and I'm going to change this exponent to a 3. So if I change this down 2 digits, that means I have to make this coefficient larger by 2 digits. So now this is 230 times 10 to the third. Now, I know what you're thinking. You're thinking, now, Mrs. Lee, you just told me I couldn't have that written like that for scientific notation. You're right, we can't, but we're trying to add these two. So I'm going to move this over now that I've changed this. So this makes this a little bit easier, okay? I'm adding these two things, and they are both now in the same exponent. So now I can just add them, just like I would anything else. It would be 231.8037 times 10 to the third. So notice what I did. All I did was add the coefficients, and then my exponents stay the same. Now we have to go back and we have to think about what our significant digits rules would be. I have to go to the least precise, because remember, I added these two. My least precise here is to the whole number. Here I have 4 decimal points. Least precise is to the whole number, which means I have to get rid of 8037. But don't forget that 8 is going to make this pop up 1. Okay, so this becomes 232 times 10 to the third. And there's one more step, because what's wrong? This has more than 1 digit to the left of that decimal point. So 2.32. So if we reduce this by 2 digits, we got to take that up 2. Now we just learned a pretty good lesson, actually, because if we look at this, if we had just changed this 3 to a 5, we wouldn't have had to make those corrections at the end. But I think you're going to start to figure those out once you get a little bit of practice. Okay, let's do B. So B is a little bit easier, and I say this because this is multiplication and division. Now the only thing that I'm going to say that you have to do here, and I'm going to copy this over so you can really see what I'm doing. Okay, when I put this in my calculator, and you can certainly do that, you have to put parentheses. I'm putting a parenthesis there, and I'm putting a parenthesis, whoops, I don't want that, there. I don't know why that one's so large. That one's kind of silly. But make sure you're putting that in your calculator just like this. Because if you don't, your order of operations is going to be messed up. And what I mean by that is it's going to, your calculator is not going to know what to divide and what to multiply. What it's going to end up doing is it's going to take that 3 and multiply it by 2. And that's your exponent. So you don't want to do that. Make sure that you put parentheses. I always say parentheses are your friends. The more you have, the better it is. Okay? But you can go ahead and put that in your calculator. And when I do that, I have 12.3 times 10 to the third. Okay? And if you don't know how to put these in your calculator, you should probably come see me. Okay? And make sure that we can get that ironed out. So when I put this in here, my calculator says the answer is 246. 246. So let's go over here. Since this is multiplication and division, I just have to go by the least number of sig figs. This number has 4. This number has 2. This has to then reduce to 2 sig figs. This rounds up, that 6 rounds that 4 up, this becomes 250. All right, let's try the next one. That one is subtraction, so that one's going to be a little bit more difficult like the one we did earlier. Okay, we've got 1.32 times 10 to the negative fourth minus 0.06 times 10 to the negative sixth. Okay, first things first, when I'm subtracting these, I have to make sure the exponents are the same. So I'm going to go by the highest one this time. I didn't last time, the highest exponent. I'm going to this time, and let's see if that helps us out any. So I need to change this negative 6 to a negative 4. So when I change this to negative 4, which is 2 digits higher, I need to make this 2 digits lower. I'm going to move this exponent 2 places. So now instead of 0.06, I have 0.006. Let me make sure I did that right. Yep. And this is times 10 now to the negative fourth. Again, I took this exponent, I made it higher to the negative fourth, so then I had to lower the coefficient. So let me move this over. Now you could just put those two in your calculator, right? 12.32 minus 0.00006. Well, I'll go ahead and stick this in the calculator. And it says I get 12.3194. We keep the exponent the same. I've got to the negative fourth. And then we're going to go back and look at our least precise. Remember, those are the rules for this. And this goes out 2 digits, and this goes out 1, 2, 3, 4 places. Okay? I can only go out 2 decimal places here. So that means I have to get rid of the 9 and the 4. This 9 pops that 1 up. So this is going to become 12.32 times 10. So sorry. There's nothing I can do about it. To the negative fourth. Now, it's not done yet, because the error is you still need to move that decimal point over 1. So 1.2, hopefully that the barking wasn't too hard on your ears, so sorry, times 10. Okay, so if we move this over and make this lower, then we have to make this higher. That is going to be to the negative third. Okay, 2 more, but the last 2, if you look, are multiplication and division, so those will be a little bit easier. So D, if you take those, and again, don't forget to use your parentheses, okay? And you're going to multiply those 2 together, and I get, my calculator says I get a huge number. Actually, this is D, and I have 2, 4, 0, 4, 1, 2, 3, 4 zeros. Okay, my rules for sig fig say there's 5 significant digits here, but only 1 here. So I have to round this all the way to here and still represent the magnitude of this number. So I'm going to put 2 times 10 to the 3, 4, 5, 6, 7. I still have 1 significant digit, and yet I have completely represented the magnitude of that number. Okay? All right. You know what? I did multiplication instead of division. Let me fix that for us. There we go. Sorry. My calculator, you were probably wondering. My calculator here says 120200, right? Sorry about that. But for D, we need to take it to 1 significant digit. So again, I'm going to have to get rid of everything but that 1. So this is 1 times 10 to the 5th. Okay. Let's try the last one here. E. 1.700 times 10 to the 6th. And we are multiplying this one. And I get 340 is what my calculator says. I have 1 significant digit here. I have 4 there. I have to reduce this to 1. This becomes 300, no decimal point. All right, for practice, if you're still working with some of the Sig Fig stuff, I'm going to highly recommend in the Sig Fig folder. It just has some good resources in there to help you out. There's a summary page, there's a resource video, and then there's all kinds of practice, 1, 2, and 3, and also the Sig Fig activity. Good stuff. A lot of these things give you instant feedback, so it'll let you practice it and not have it graded. Okay? Hope you found this helpful, and I will see you soon.